Let's be honest, we are living in the middle of a full-blown AI explosion. One minute you're just hearing about it, and the next you're seeing incredible art generated from a simple sentence, or watching AI write code for you. For years, machine learning felt like this clunky, academic thing. And now, all of a sudden, it's everywhere, and it's actually shockingly good. Yeah, it really does feel like tools like ChatGPT and Midjourney just appeared out of thin air, right? Like an overnight success story. But we all know that's never how it really works. The truth is, this overnight success was decades in the making. So, in this explainer, we're going to pull back the curtain on the story of deep learning and figure out how we really got to this moment. So here's the game plan. We'll kick things off by breaking down what deep learning even means. Then we're diving into the pretty wild history of AI, all the booms and the busts. After that, we'll uncover the three key ingredients that finally made it all click. We'll even take a quick peek inside the mind of these networks, and then we'll wrap up by looking ahead to what might be coming next. All right, let's get right into it. The term deep learning sounds super complex, but it's not really one single magical thing. It's actually the combination of two core ideas that work together. You have an architecture, and you have a method for learning. Okay, so ingredient number one is the architecture, and that's the neural network. The easiest way to think about this is as the machine's blueprint. It's loosely, and I mean loosely, inspired by how our brains are structured, with layers of simple little calculators all stacked on top of each other. This layered design is what gives it the power to tackle ridiculously complex stuff. It's the whole foundation. But a blueprint is useless if the machine can't actually do anything, right? It needs a way to learn, and that's our second key ingredient. It's a really clever mathematical process that acts as the learning engine. So imagine the network has millions of tiny little dials it can turn. This process lets the machine automatically tweak every single one of those dials just a little bit at a time, getting closer and closer to the right answer with every single try. It's how the machine actually teaches itself. Now, you'd think with ideas this powerful, the road to success would be a straight shot, right? Well, not even close. The history of AI is honestly a total roller coaster. It's a story of huge hype and excitement, followed by absolutely crushing disappointment, and periods where all the funding dried up, what people call AI winters. So the story really kicks off in 1958 with this thing called the perceptron. It was brand new and everyone went wild, thinking the future was here. But that hype train came to a screeching halt. By 1972, a critical book came out that exposed all its limitations, and the field just went cold. We got a little glimmer of hope again in 1986 with a new technique that made the networks more powerful. But even that wasn't enough to stop the great AI winter around the year 2000. And then, 2012, a model called AlexNet just completely shattered all the records. And boom, the winter was over. The modern AI revolution had begun. And if you want to know just how brutal that AI winter got, check this out. In the year 2000, at the biggest machine learning conference in the world, if you submitted a paper and it had the words neural and network in the title, it was actually more likely to get rejected. I mean, can you imagine that? The whole idea was so unpopular, it was basically a bad word. So this is the million-dollar question, right? After decades of these false starts and huge disappointments, what was so special about 2012? Why did deep learning suddenly explode onto the scene and start working so incredibly well? Well, the answer wasn't one singular aha moment or breakthrough. It was more like a perfect storm. The convergence of three absolutely crucial factors that, for the very first time in history, were already at the exact same moment. First, you need fuel, and that fuel was big data. We finally had these huge, hand-labeled datasets like ImageNet with millions of images ready to go. It was the perfect food for these incredibly hungry algorithms. Second, you need an engine, a seriously powerful one. And this part is kind of genius. Programmers figured out that the graphics cards used for video games, GPUs, were perfect for the kind of massive parallel math that deep learning needs. And finally, you had the blueprint. The algorithms themselves, ideas that had been sitting on a shelf for decades, were suddenly ready for prime time, finally ready to be unleashed on all this new data and hardware. Okay, so we've got the data, the hardware, and the algorithms, the whole setup. But what is actually happening inside that machine when we say it learns? Let's take a quick intuitive peek under the hood. The real magic, the secret sauce, is in the deep part of deep learning. A network with just one layer is considered shallow, and it can only solve really simple problems. It's kind of like trying to separate two groups of dots by drawing just a single straight line.
But when you start stacking those layers, making the network deep, it suddenly gains this superpower. It can draw incredibly complex, curvy, intricate boundaries. It can solve problems that are way, way more complicated.
So how does it figure out where to draw those crazy boundaries? Well, it's basically a giant, lightning-fast game of trial and error. First, the network takes a wild guess. It says, okay, I think this is a picture of a cat. Then it checks the right answer and calculates exactly how wrong it was. And here's the cool part. It uses that error to go back and fiddle with millions of its internal dials, tweaking each one just a tiny bit in a direction that would have made its guess a little better. And then it does it again, and again, and again, millions, even billions of times, until it becomes a master cat spotter.
So, that brings us right up to today. We've gone through the history, we've peeked under the hood, but the question that's on everyone's mind is, what comes next? Where is all this going? When you zoom out and look at that roller coaster history we talked about, a fascinating pattern emerges. The first two major hype cycles, from peak excitement to the next peak, each lasted for about 28 years. Our current boom started in 2012. If that pattern holds, that puts us 14 years in, right smack in the middle of the current cycle.
And that leaves us with a huge, fascinating question. Are we just at the beginning of an even steeper climb? Or are we maybe approaching the peak of another great AI bubble? History gives us a clue, but the future is really anyone's guess. So I'll leave you with that to think about. Where do you think AI will be in 2028?